and speeds. Cyclic load is what? The load which is acting in a variable condition at different time limit. For different time limit we have such types of load. Suppose x load is there for x rpm, for y rpm, for z times of, okay, in this way different times, at different time different rpm different loads are acting. This is one of the variable loads. So for bearing, the cycling loading condition is being considered in this. Now let's see, this is an example shown here that the radial load of 2500 newton at 700 rpm for 25% of the time. Same thing for 5000 newton at 900 rpm for 50% of time, and 1000 newton at 500 rpm for the remaining 25% of the time. That means for 100% of time, this time is been divided in these cycles. So we can't solve this, because to find out the equivalent load we need the radial and the axial component, but these are the variable condition. So now let's divide this thing in a elements. So let's, it is an x element. So P1, P2 will be the loads, N1, N2 will be the speeds, and L1 is the corresponding to load P1. So L1 is equal to what now? C upon P1 cube in 10 to the power 6 million revolution. So we can say that 1 upon L1 is equal to P1 cube by C cube in 10 to the power into 1 upon 10 to the power 6. If suppose N1 is added here, so the equation as in this way, that is N1 P1 cube upon 10 to the power 6 into C cube. For next element N2 will be there. Like this, n x times of we can add it. So this equation we get here. Okay. Now equivalent load is equal to what? N is equal to N1 plus N2 up to last Nx. So equivalent load, the equation मिलेंगी equivalent load के लिए वो क्या रहेंगी? That is N P cube upon 10 to the power 6 by C cube. Now from the A and B, this A and B, we will get this term, that is N1 P1 cube plus N2 P2 cube plus Nx Px cube equal to Npe cube. Based on that, we made this formula. This formula is important for us to find out the equivalent load for cyclic loading condition. I think you can see here the above equation is used for calculating dynamic load capacity and does not vary in steps of constant magnitude but varies continuously with time. Above equation is again modified and it is written as for integration condition 0 to n p cube dn upon 0 to n dn, or in this way. So the last equation is the best equation for us. We can use that equation to solve the cyclic loading condition. Thank you very much.